G'day, this is noisy birds. This is a very interesting setup I've got here, novel at any rate. So what I have is, I'll explain all the bits and pieces to you. So the liquid that you see is derived from wood ash. There it is in there. I've got it out of the fireplace, added water. You get a layer of yellow liquid and it sits on top. You pour it off, you filter it like there, and there you have your electrolyte. So what I did was I've got aluminium as negative and copper as positive. Well, that's probably better. So now what I've done is to get it up to enough voltage to provide enough power for this little lamp to go. I've got it just two in series here. So it goes double up like a double cell type thing. What I found interesting is it's rechargeable. So what happens is when you first put it in, our aluminium goes black. So it's oxidised. That occurs for various reasons, but it's something to do with the amount of oxygen in the water, maybe sodium hydroxide, other oxygenates. It's very hugely alkaline. This is probably 13 or 14 pH. But what I found was when I charged it up, the copper, instead of an electrolysis thing happening where the aluminium would coat the copper, the actual copper's gone green, which is copper oxide. So that's very interesting. There you go. Now, the other thing that happened was my aluminium, I don't know if you can see there, that the aluminium oxide was actually coming off during the process of charging. So obviously that's going to go black again, and my guess is that our copper oxide will fall off. So we can have a look at that. Yeah, maybe not too much. It has a bit. Anyway, what sort of voltage we got? We got 2.5, because I just waved it around a bit. As you can see, it's really going down very slowly. So that's very interesting, a very interesting novel rechargeable battery. A double oxidation reaction, maybe? I don't know. Anyway, it's interesting. So I'm going to charge it at 10 volts. You can also see before I charged it that its internal voltage is going up again to find equilibrium. Alright, so let's turn it on and 10 volts, and we'll have a good look at what's going on here. 7 milliamps. So that black oxidative layer is coming off there and going into solution. This one, where is it? Not so much at the moment. I'll have to try and find out what's going on there. Oh, it is starting to go now, probably because it's a bigger surface area. But that black oxidation layer is being liberated. You can see it coming off actually. And that's the process that I've been using to and that copper will go greener. And now, of course, because there's more resistance, the chargeability has to go up, so the milliamps have gone up for charging. Anyway, we might pull the pin on that there and see what let's have a look, what's it charged to? 8.92. So slowly going up. So it's not the greatest Definitely would not call it the greatest rechargeable battery, but it may merit some investigation. So now I'm going to disconnect it. .1 and going down as you'd expect. Alright, so let's put our light on there, nice and bright again, and you can see that's going down quite readily. That will slow up. Actually, that will last for quite a few hours now. That's what I found. So it's a good novel rechargeable battery. So once again, wood, ash, electrolyte, just aluminium, could be aluminium can or whatever. Oh, hang on a sec, I'll show you. Just here to demonstrate that you can clearly see the black oxidative layer coming off there, so that's interesting. And this one you can see actually how clean it is, really clean now. So what's going to happen is the reverse is going to happen. The oxidation layer on the copper will come off and the black oxidation of the aluminium will reoccur. It'll actually go black again. So what have we got stabilised at 2.9 volts, thereabouts. Hang on a sec. So there you go, 2.713, slowly going down. Got plenty of grunt in there. Should probably try some graphite, a graphite rod or something like that. And so I'll probably do that on the next experiment. But that's an interesting double oxidation reaction battery. Alright, catch you later.